Okay, so today we're going to talk about mass to mass stoichiometry. So we're going to be given a mass of either one of the reactants of the products, and we're going to have to find the mass of one of the reactants of the products. So let's use this chemical equation. 4 moles of iron reacts with 3 moles of O2 to yield 2 moles of iron oxide. So we can see we have a 4 to 3 to 2 ratio. All right, here's our example problem. If 25 grams of iron reacts with an excess pen is not working of O2, what mass of iron oxide is produced? So we can see that we have been given the mass of iron, not the moles this time. So we're going to first need to do a conversion from mass into moles of iron. Then we can use our molar ratio of iron to iron oxide, because those are the two substances we are concerned about. 4 moles of iron is producing 2 moles of iron oxide. And then at the very end, we're going to convert moles of iron oxide into grams, mass of iron oxide. Now this is going to end up just being one big, long dimensional analysis problem. And we're going to start by converting mass of iron into moles of iron. And we need to know that the molar mass of iron is 55.8 grams per mole. So we start with what we're given, 25.0 grams of iron. Okay, first we convert mass of iron into moles of iron. So we know that 1 mole of iron is equal to 55.8 grams of iron, again from the periodic table. And we put the mass of the iron on bottom because we want it to cancel with the mass of the iron on top. So we do that. And now we're left with moles of iron. Now we get to use our molar ratio of iron to iron oxide. The problem said we had an excess of O2. So we don't care about the O2 in this. We're given the amount of iron, and we're asked to find the amount of iron oxide. So it's that molar ratio that we are concerned with. Again, the 4 to 2 molar ratio. So I have moles of iron on top. I need moles of iron on bottom. So 4 moles of iron to 2 moles of iron oxide. So now moles of iron on top, moles of iron on bottom, and I have now converted everything into moles of iron oxide. Finally, we need to convert from moles of iron oxide into mass of iron oxide, because that's what we were asked to find. And again, we need the molar mass of iron oxide, which is...
Friend loader, you're right in here. Friend loader, you're right in here.
That's a nice interruption. The molar mass of iron oxide is, if we look on the periodic table, 159.6 grams per mole. So 1 mole of iron oxide on the bottom and 159.6 grams of iron oxide on top. Again, I put moles of iron oxide on bottom, so it would cancel with moles of iron oxide on top, and we're left with a unit of grams of iron oxide, which is exactly what we wanted because the problem asked us to find the mass of iron oxide produced. So the last step in any dimensional analysis problem is we multiply everything together on top, and we end up with 7,900. Mr. Maddox, your pen is not working. There we go. 7,980 divided by everything on the bottom, 55.8 times 4, which gives us 223.2. And we end up with our answer, 35.8 grams of iron oxide. Last step in any sort of word problem is to figure out if our answer makes sense. It's not ridiculously huge. It's not ridiculously small. Keep in mind we started out with 25 grams of iron, so it makes reasonable sense that we end up with 35.8 grams of iron oxide as a result. What I want you to notice is that we are basically just adding on to the problem we did yesterday in class. Yesterday, we were dealing with essentially this, which I've outlined in blue. The only thing that we've done is added on something in the front, and that was a conversion from mass to moles, which I've outlined in purple. The heart of everything is still this molar ratio in the very middle. And again, that 2 to 4 ratio comes from the balanced chemical equation. 4 moles of iron to 2 moles of iron oxide. Okay, let's do another example problem. And this time, we're going to do a problem where we just look at the reactants. So for this example, I don't want to write in green. How about black? For this example, and the pen's not writing now. Ha! What mass of iron is needed to react completely with 12.6 grams of O2. Again, we're using the same equation. We have 4 moles of Fe plus 3 moles of O2 to yield 2 moles of Fe2O3. So we're going to set up this problem the same way we did the last one. Start with what we know, and we're going to start way over here. 12.6 grams of O2. Let's try that again. Pen doesn't seem to want to work. 12.6 grams of O2. And now remember, we have to get to the heart of the problem, and the heart of the problem is using the molar ratio. And we're concerned this time with iron and oxygen. So our molar ratio is going to be 4 to 3. But to use that molar ratio, I got to get the moles first. So first we're going to do a mass to moles conversion. Okay, so 1 mole, I'm writing in red now, of O2 is 16, let's try that again, 16.0 grams of O2. I put grams of O2 on the bottom because I want it to cancel with grams of O2 on top. Next step, we've got moles of O2. Let's use the molar ratio. So it's 3 moles of O2 to every 4 moles of iron. Again, moles of O2 on the top cancels with moles of O2 on the bottom. And now I've got moles of iron. The problem didn't ask me for moles of iron, it asked me for mass of iron. So we've got to last convert from moles of iron into mass of iron. So 1 mole of iron is equal to the molar mass of iron, which is 55.8 grams. So moles of iron on the bottom cancel with moles of iron on top, and we are left with the unit of grams of iron, which is the mass. So we multiply everything together on top and everything together on bottom. So when we multiply everything together on top, we end up with 10, 2, 8, 1, 2.32. And when we multiply everything together on bottom, we end up with 48. Doing the math, we get 58.6 grams of iron. Mr. Maddox needs a new pen for Christmas. That is it in a nutshell. And if you need a little helpful mnemonic to walk you through these problems, it's essentially, we're going to go from mass to moles, then we're going to use the molar ratio, which is going to give us moles again, and then finally we're going to go from moles back to mass. So, I mean, really, it's just mass to moles, moles to mass. That's the heart of every mass-to-mass stoichiometry problem. You guys have the homework to work on. It's the back side of last night's homework, and it'll be due tomorrow. I'll see you tomorrow.